Go. Hey, Google. English guy. Stop talking. Pause. All right. That's cool. So I have here, I have this problem. I've got a Yamaha 3M30. It's a three-cylinder diesel 2009. There's white smoke appearing around 2,200 RPMs, and I put it online, and I just got like 18,000 explanations as to what's going on. Since it's white and not gray, it's either coolant, steam, fuel, caused by possibly a gasket, overheating, bad injector, leak with the coolant, all sorts of stuff. At the core of all four of those, for me trying to figure it out, I needed some sort of heat sensor. I was going to look for a heat sensor gun, which is an infrared line of sight. Point the laser, it does an infrared temperature, it tells you, and you just point at different parts of the engine, and you have to write that down. And instead, I went out on the internet, and I found this barbecue temperature sensor gauge. It has Bluetooth, and it has a freaking app, which you can't see. It looks like the lighting's off. And it has an app. So just to simulate the app, what I've done, what I'm going to do is I'm going to put it on the engine, and I'm going to put one of the probes on the elbow joint, which is the mixer of the engine coolant after it's gone through the heat exchanger and into the exhaust. So it's a muffler slash exhaust for the coolant, for the fresh seawater that comes in. And I'm going to take it, it's a commonplace for problems. I'm not going to go into the details, but let me get through this. So I'm going to put a sensor at the elbow joint. I'm going to put a sensor in the head of the engine. I'm going to put a sensor on the crankcase, which is effectively oil temperature. I'm going to put in a sensor on the freshwater coolant intake after the heat exchanger. Actually, I'm just going to put it on the heat exchanger, a lot of words, which is going to give me the coolant temperature. And then I'm going to put it on the manifold, which is the exhaust. And then the last one, I'm going to have the ambient temperature. And the ambient temperature is really key because it could just be the temperature of the engine compartment itself hits a threshold and throws everything else off. So all you'd have to do is have a blower, and that would reduce it down to a certain level. But that's just another topic I'm reserving for it. So what I did to simulate how it works and to show you, it has sensors. And what I did was I put a sensor on my laptop. I put a sensor on the back vent of this 110 volt LCD monitor, 22 inches. I think this is 22 inches also, but this is a 12 volt, like the one I have on the boat, and there's a sensor on that. And then there's a sensor on this LED light bulb, and then there's a sensor on this incandescent light. It's kind of a hybrid fluorescent something, I don't know. And then there's an ambient temperature, which is down below, which is just, you can't see it. You gotta take my word for it. Which is just the room temperature, and the air conditioner's on. So that is simulating, some interesting data about that. So what I'm gonna do is, what I've done is I've mapped each of those sensors and renamed them. And this application keeps track of temperatures, it keeps track of timer, it's Bluetooth based, it sends alerts off, it can send me a text message or an email. It has a graph, so you actually have a graph of each of the sensors and what's going on with them. And what I'm going to do now is just show you the sensors that I have. Sensor number one is the laptop. It's currently at 86 degrees with a 102 threshold alert. The next is the 110 volt LCD, which is 100 with a 110 alert. The next is the incandescent bulb, which is at 79, which is almost at room temperature, with an alert of 195. Look at that delta, huh? That should tell you something. I was surprised about how hot those light bulbs get. There's a room temperature, which its outdoor temperature is 86, the indoor 75, and it has a huge impact on the numbers of the other temperatures, and I'll show you that later. The LCD at 12 volts, which is TV in front of me, LCD TV in front of me, which is a lower wattage and lower voltage. It doesn't burn as fast, as hot as the LCD 110. And then lastly, the LED light, which is at 81, which is slightly higher than room temperature. You know what the interesting thing about that is that the incandescent light cooled down faster than the LED light, and the incandescent light got at a much higher temperature. As you can see in detail in the graphs, you could actually see the curves of it slowing down, cooling down. There's the LED light, and that's the curve that it's warmed down. And then the fluorescent light, the scale there, you can see it was like one, wow, that's bad data. But let's move on. What I'm going to do is I'm going to turn on these lights. I'm going to first turn on the LED, and then I'm going to turn on the incandescent. And now you'll start to see real data flow in here. And right away, you see a hockey puck. Why is that out of focus? Work. Go away. Right away, you can see a jump, and you will see a jump. And then if we go back to the monitoring screen, you'll see a temperature start going up for that. See, it's at 90. It's at 91, and the same too for the LED. It's at 84, 86. And we can see that in the graph in 75. And basically, long story short, what I'm going to do is I'm going to use this product, to troubleshoot the problem by getting the information about all those data points in order to more accurately determine that. And there you go. Oh, there's the boat right there with my buddy Evan driving it, and hopefully we can get back out on it soon. That's it in a Catalina at Two Harbors.